What if I told you it's possible to play on your classic computers completely wire-free, using a modern gamepad or even a mouse over Bluetooth? I've always been a big fan of classic joysticks like the Phasor One, which, as you can see, is pretty worn out after years of use. But lately I've been using this wireless Atari gamepad more and more. That said, it's not the most ergonomic option, and the control doesn't feel quite as precise. But it does work wirelessly, and it's compatible with any system that follows the Atari standard 9-pin joystick port, like the Commodore 64 or the Atari ST. A might alternative is Unijoysticle, an open-source project which lets you connect Bluetooth controllers and mice to your classic computers. I've been wanting to try this for a while, so let's get started and see how it performs. We're going to assemble the board ourselves. It doesn't require much soldering skill since it uses through-hole components that are easy to work with, easy to find, and inexpensive. I found a slightly older version on PCBWay. There are newer versions that use surface mount components, but the one we're using in this video is still supported by the creator and offers the same features as the newer designs. There are also different versions with varying sizes, depending on the computer you want to use it with. In my case, we'll be using the version designed so that the joystick ports line up with those on a Commodore 64. But you can use it with other systems as well by using joystick port extension cables. The assembly process is very straightforward, and you can find the full list of required components in the project's repository. Once the device is assembled, the next step is to flash the firmware onto the ESP32 development board, which is what Unijoysticle uses to handle the Bluetooth signal and translate it into something our classic computers can understand. You can find a detailed guide on how to do this on the project's website along with the latest version of the firmware. This version of Unijoysticle can be powered in several ways, directly through the ESP32's USB port, using an external power supply with a barrel connector, or even powered from the computer's joystick ports. In my case, I tested a couple of ESP32 boards, one with a micro USB port and another with USB-C. Both required more than 100 milliamps to start up. The USB-C board didn't go much beyond that, but the micro USB one reached around 176 milliamps. That doesn't seem like a safe value for a Commodore 64 since its joystick ports aren't designed to power external devices, and the circuitry is quite sensitive. In fact, the micro USB board wouldn't boot when powered from the computer on startup on any of the systems I tested. It only started reliably when powered externally. However, once it was up and running, it continued to work even after disconnecting the USB power cable. The USB-C board, on the other hand, seems to be more power efficient and boots without any issues on all the systems I've tested. That said, this project has made me realize how little I actually knew about the power capabilities of joystick ports across different classic systems. The results with this device are excellent. It's very responsive, and as it comes assembled, it's basically plug and play. I've tested it with a lot of games, and even in those that require fast reactions, the response has been quick and precise. You've probably also used other adapters that let you connect USB mice or gamepads to your classic computer. One of the most interesting advantages of Unijoysticle is that it can also work as a mouse receiver, as long as the mouse uses Bluetooth. The device can also be configured by connecting to it via a terminal over USB. From there, you can adjust things like controller behavior, auto-fire speed, or how the mouse operates, whether it emulates an Amiga or an Atari ST mouse. Although it offers quite a few configuration options, in most cases you can use the device without any issues using the default settings. The only real downside I've found so far is occasional disconnections on some systems, although I haven't been able to pinpoint the exact cause. On the Commodore Amiga, the disconnects were quite frequent. However, on the Commodore 64, I didn't experience any issues at all, so it might come down to the quality of the ESP32 boards I'm using, or possibly differences in power stability or signal noise between systems. Overall, I'm really happy with how this device performs. It works very well in general, and it's a great way to connect modern gamepads or mice to our beloved classic computers. Another fantastic way to enjoy the games we grew up with. That said, maybe it's just nostalgia, but I still love classic joysticks. For me, they remain the most authentic way to experience these systems. Even so, modern devices like this can help bring new generations closer to that same experience, and to what was truly the golden age of video games. I hope you enjoyed this video. Let me know in the comments if you'd like to see more videos like this, exploring modern hardware for classic computers. If you liked it, don't forget to hit the like button, and thank you so much for watching all the way to the end. See you in the next one.